Hello, my friends. How are you doing, my friends? So, let me silence my phone. In 45 minutes, I have a meeting. Therefore, we have only like 45 minutes or a bit less. So I said, let's take advantage of the time, this opportunity, and let's watch some videos on machine learning from Andrew NJ or Ng or NG, whatever, because we want to constantly get better at machine learning. That's it. Let's machine learning, guys. Let's machine learning. I wanna do machine learning for the rest of my life. I don't wanna do that. But we have to know it. It's like basic stuff, right? So, we did machine learning. We did machine learning. So yesterday, all right. Now, okay, I can close this. Cancel, no. Recompile. What do you mean connection loss? What's happening? All right. Chill. Whew. My laptop is fucked now. Guys, I had the energy. Let me connect it to the charger. Maybe it needs some fresh electricity. Alright. What happened? Like the fucking shit. Okay. We are connected. Good. Let's go this one. YouTube. And Stanford lecture, Dancing Cells, Dr. Don Noose. L'experiment, Andrew Ng. But what we want to watch is Stanford CS 229. We are at lecture 8, last parts. How many lectures? 20 lectures. To be honest, we went through 8 lectures and nothing is special. Let's get more involved with this shit. All right.
And then there's one even more extreme version of this, which you should use if you have very, very small data sets. So sometimes you might have an even smaller data set. You know, if you're doing a class project with 20 examples, that's small even by today's machine learning standards. So there's an extreme version of k-fold cross-validation called leave one out cross-validation, which is if you set k equals m, right? So in other words,
By the way, I used to watch these videos on 2x. There is no point in that. What is the rush for learning? We have time. All those stuff I learned in 2x. What happened to them? Where are they? I don't use them anymore. Don't learn the stuff you don't want to use,
here's your training
but
set.
in a
with
constant
20
manner.
examples. So you're going to divide this into as many
Phases.
pieces as you have training examples. And what you do is
Gaussian,
one example,
ChatGPT.
train on the other 19, and test on the one example you
it.
held out. And then leave out the second example, train on the other 19, and test on the one example you held out. And do that 20 times, and then you average this over the 20 outcomes to evaluate how you
Okay, I'm remembering. It was about the part that
the huge downside of this is
data
it's
set
very,
was
very
small.
expensive
We could
because
do
now you need to train your algorithm m times. So
n times.
you kind of never do this unless m is really small.
Uh-huh.
I personally have I pretty much never use this procedure unless m is 100 or less. I guess you know if your model isn't too complicated, you can afford to fit a linear regression model 100 times. Like it's not too bad. Right. So if m is
Size of data is small.
if m is 1,000,
We don't want to
fitting a model 1,000
do a lot of
times,
shit,
then usually
right?
it's
Do a lot,
but if
like
you do have
70%
examples,
to
then, you know, I would
training set
20
with
examples, I
test
would
set.
probably use this procedure. And
So
somewhere between 20 and
we
50
divide the data set to
switch over,
k,
leave one out to-
and each time we leave one out as our training or test set. Leave one out. Is the method's name is leave one out. Error.
Yeah, so, right, so since you have k estimates, say 10 estimates, you're using 10-fold cross-validation, can you measure the variance on those 10 estimates? It turns out that those 10 estimates are correlated because each of the 10 classifiers, 8 out of 9 of the sets of data they trained on overlap. So there was some very interesting result. There were some research papers written by Michael Kearns actually, it was like a long time ago, trying to understand how correlated are these 10 estimates. And from a theoretical point of view, as far as I know, the latest theoretical result shows that this is not a worse estimate than training error, but maybe showing us in practice is not, you could measure it, but we don't really trust that estimate of variance because we think all 10 estimates are highly correlated, or at least somewhat correlated. Whether I recommend using k-fold cross-validation deep learning. If you have a very small training set, then maybe yes, but deep learning algorithms depend on the details, right? Sometimes it takes so long to train that training a neural network 20 times, you know, seems like a pain unless you have enough data, unless your neural network is quite small, right? So it's rarely done with a deep learning algorithm. But if you have frankly, if you have so little data, if there are 20 training examples, you know, there are other techniques that you probably need to use to boost performance, such as transfer learning, or just more managing of input features or something else. Right? Yeah. Sorry, Sylvia? Oh, sorry. Thank you for asking that. This average set, no. I meant averaging the test errors. So here, you will have trained 10 classifiers, and you know when you evaluate it on the left out 1/10 of the data, you get a number, right? So you're looping 10 times. Hold that one part, train on the others, test on this part you left out, and so that'll give you a number. They will say, oh, when you test on this part you left out, the squared error was 5.0. Do it again, square error was 5.7, square error was 2.8. So by average, I meant average those numbers. And the average of those numbers is your estimate of the error of a, you know, third order polynomial for this problem. So this is an averaging a set of row numbers that you got from this. So this loop gives you k row numbers, and so this is averaging those k row numbers to estimate this outer loop how good a cos phi with that degree polynomial is. Okay. Well, actually, a lot of questions. There's one thing I forgot. Go ahead. There's lots to go.
Recall. Other than this average, who is this guy?
I see.
Who is this? This guy in the class is like.
And for this outer loop, how good a cos phi with that.
Can you hear him?
Okay. Well, actually, a lot of questions. There's one thing I forgot. Go ahead. There's lots to go.
Okay, the subscription, the caption is like inaudible. Alright. Oh, slightly.
Sure. Yes, if it's something on an F1 score, would it do something other than average? Yes, it would. Having F1 score is complicated. Yes. I think we'll talk. Actually, so this week Friday we'll talk about learning theory. Next Friday we're talking more about performance evaluation metrics. So we're actually going to talk about F1 score. All right, Rich, one last question. Oh, sure. How do you sample the data in these sets? So for the purpose of this class, assuming all your data comes from.
What is your favorite
I would usually randomly.
Greek letter?
Again, in the era of machine learning and big data,
I
there's
hate
one other interesting
Zeta
trend is which
or
just wasn't
XC.
true 10 years ago, which is we're increasingly trying to train
Phi
on
is good.
sets.
Psi is
We're
good.
trying to, train on data
Eta is good.
collected in
Alpha is
context
good.
and
Beta
applied to
is good.
totally different contexts.
Gamma
Such
is
as,
good. Lambda
we're
is
trying to,
good.
train on speech collected on your cell phone.
What
all
else?
that data, and trying to apply it to a
Alpha, beta,
to a
gamma,
smart speaker,
lambda.
just collected on a different microphone in your cell phone or something. So
Nu is
if you
good.
are doing
Mu
that, then
is
the way
good.
you set your train depth test is a bit more
Um,
complicated. I wasn't going to talk about it in this class. If you want to learn more, I think at the start of the class I mentioned
Kappa
this book, Machine Learning.
is good.
So that book is finished, and if you go to this website, you can
Sigma.
get a copy of it for free. That talks.
Not bad.
And I also talk about
This one is the most difficult.
which goes more to
Zeta.
But you can go and
Or
you can also
its
do all
brother.
this in machine learning.
XC.
If the training test sets are different.
Tau is good.
Yeah, but random shuffling would be a good default if you think your training test sets are
All
too
the
different.
Greek letters.
All right, just one last thing I want to cover real quick,
Omega is good, but it's actually a W.
which is feature selection.
Rho is good. And all of them I'm talking about
And so,
is lowercase.
So let me just describe one. So sometimes you have a lot
Alpha,
of features.
beta, gamma,
so actually let's take
delta.
a text
Delta is
application.
good. Delta is
You might have
nice.
10,000
Epsilon
features,
is
that's
good.
10,000 words, but you might suspect
Zeta
that
is
all the
bad.
features are
Zeta is disgusting. I hate Zeta. I'm not good at writing Zeta. And I hate Zeta. It's not a Z, it's like it has a curve and it makes it like it doesn't go all the way back. So Zeta is disgusting.
not important.
Eta is
You
good.
know, the word D, whether the word D
Theta
is
is
called a
good.
soft word, whether the word D appears in email or not.
This
doesn't
one
really
I
tell you
haven't
what's
seen. L, it's like L, small L. And it's not good, to be honest. It's not used a lot, it's not good. Kappa is good, lambda is good, mu is good, nu is good. This one, 3 line or whatever the fuck it is, this is even worse than zeta. It is like 2 zeta in a row. And I hate it the most. This is a sign that if there is a whatever it is in a conversation, I won't engage. O, they have O. Pi is amazing. Rho is good. Sigma is good. Tau is good. I haven't seen this one. Phi is good. X is good, size good, omega is. So there are like 4, maybe that 3 that are not good. What happened to the
for your task, right? And so this takes judgment.
feature selection?
These are
What features should we select?
Tell you much about the content of the email. But so if there are a lot of features, sometimes one way to reduce overfitting is to try to find a small subset of the features that are most useful for your task. Right? And so this takes judgment. There are some problems like computer vision where you have a lot of features corresponding to there being a lot of pixels in every image, but probably every pixel is somewhat relevant, so you don't want to select a subset of pixels for most computer vision tasks. But there are some other problems where you might have a lot of features, and you suspect the way to prevent overfitting is to find a small subset of the most relevant features for your task. So feature selection is a special case of model selection that applies to when you suspect that even though you have 10,000 features, you only highly relevant. If you're measuring a lot of things truck is about to break down.
That's the fucking ASMR.
You might measure hundreds of variables or many hundreds of variables, but you might secretly suspect that there are only a few things that predict when the truck is about to go down, it's going to prevent maintenance. So if you suspect that's the case, then feature selection would be a reasonable approach to try.
Give me money. What are
And
these
so,
bullshits you're teaching?
I'll just write out one algorithm, which is start with this is script f equals the empty set of features.
By the way, this F, what is it? Is it Greek? I doubt.
And then you repeatedly
That's good, like for measurable sets.
try adding
That's a good F.
each feature I to f and see which single feature addition most improves the depth set performance. Right? And then step 2 is go ahead and commit to add that feature. To F. So let me illustrate this with pictures. So let's say you have 5 features, x1 through x5, and in practice it's usually more like x1 through x500 or x1 through 10.
So xi's are x1 to x5
So
are
start off with
features.
50 set of features, and train a linear classifier with no features. So the model is h of x equals theta 0, right, with no features. So this won't be a very good model, but see how well this does on your depth set. So this is you average the y's, right? So it's not a good model. Next, so this is step 1. In the second iteration, you would then take each of these features and add it to the empty set. So you could try the empty set plus x1, empty set plus x2, empty set plus x5. And for each of these, you would fit a corresponding model. So for this one, you fit h of x equals theta 0 plus theta 1 x5. So just try adding one feature to your model and see which model best improves your performance on the depth set.
So he's talking about, what he's talking about is like feature selection. Which feature adds the most to the data? Like for example, our regression task. If you want to choose a subset of data. Also, it is good, I think, what is that? Shannon, not Shannon, but there is a measure that in economics that we say how much is share of anybody in this, like in the prize we won, and then they there's this summation that says what would happen if he was not there, and now that he's there, what will happen. Let me check it. What is it? Shelling. I don't remember. All right. It was not in this one. It was in it must be 2000 and a marketplace for data. PDF. RDF. What is it? Give me the fucking paper. That is good. A marketplace for data and algorithmic solution. Should bring solution. What is the point of analyzing the stuff? Right? If you are not going to come up with an improvement or shapely value. Right. It says what would happen if we added them, and there is also a scaling factor here. Interesting.
Find that adding feature 2 is the best choice. So now what we'll do is set the set of features to be x2. For the next step, you would then consider starting with x2 and adding x1 or x3 or
okay.
x4.
So he's doing it in a greedy manner, right? First one, we choose what is the first feature that adds the most, and then we fix this one, then we look among the rest and which one adds the most, right? Maybe x1 and x2 are very close as the beginning, but once we have x2, x1 doesn't add much because they have correlation. So yeah, that's a good practice.
X5. So if your model
But do you think it is the best way? Do you think greedy is the best way? Like first x1, fixing x1, then probably x2, then x3. But if we had to choose a size 3 subset from the beginning, would it be the best? It's just an approach, it's not obvious.
Already using the feature x2. What's the other feature? What additional feature most helps your algorithm? And let's say this x4. Right? So you fit 4 models, see which one does best, and now you would commit to using the and you kind of keep on doing this, keep on adding features greedily, keep on adding features one at a time to see which single feature addition helps improve your algorithm the most. And you can keep iterating until adding more features now hurts performance, and then pick whichever feature subset allows you to have the best possible performance in that set. Okay, so this is a special case of model selection called forward search. It's called forward search. We're starting an empty set of features and adding features one at a time. There's a procedure called backward search, which you read about that. We start with all the features and remove features one at a time. But this would be a reasonable feature selection algorithm. The disadvantage of this is it's quite computationally expensive, but this can help you select a decent set of features. Okay. So I'm running a little bit late. That's great. Oh, so I think I was meant to be on the road next week, but because is still unable to teach.
Oh, what?
Road next week, but because is still unable to teach, I think we'll have Raphael teach decision trees next week, and then also Kian talk about neural networks next week. Okay, so let's break for today, and maybe we'll see some of you at the Friday discussion session.
It was good. I liked the last part. Features.
Okay, welcome everyone. So today we'll be going over learning theory. This used to be taught in the main lectures in previous offerings. This year we're going to cover it as a Friday section. However,
Okay,
some of the
guys.
concepts here are we're going to be.
I say better stop watching it for today because it's a new session. Also, in 15 minutes, I have to go talk to my advisor. We are going to talk about this last paper we are working on. What are we going to talk about? How to finish it. We want to say how to finish it. What are the left steps that are left to finish it? Because all of us feel that it has been a long time. Like January is ending, and we expected to finish this paper by the end of 2023. So we are all determined to get rid of this one. Alright, thanks a lot, like always, and